Now we're in a position to actually understand and appreciate why we want to use the cyber kill chain. So let's go back to the example of the Ukraine power grid. We saw how the attack went through. We tried to map the attack to the individual observable steps per different stages and the steps within the stage, reconnaissance to act, and develop to execute ICS attack for the two stages from intrusion, more on the IT side, and the stage 2, the ICS attack. And we saw how the attacker achieved each step individually, from phishing emails to the malware to credential theft and so on and so forth. Now, this is exactly what we can do and what we can use to create defenses and to create security mechanisms that would prevent these things from happening. Going step by step, we can look back and see what can we do to ensure this never happens again. Phishing emails, for example. How can we prevent phishing emails in organizations? An example is always more awareness and training of the employees. You ensure that they sign up for training programs where they learn to recognize phishing emails. You train them, you talk to them, you ask them whenever they're not sure to talk to someone, to talk to IT, forward emails to IT if they think they're suspicious, or never open attachments. Maybe you create a policy that you should never open an attachment without specific approval from someone who can investigate whether this will be something malicious. So that's how, for example, you can reduce the effect of phishing on your organization. And then, since a specific type of malware was in place, you have to see why this was not detected by your antiviruses. Were your antiviruses not up to date? Are you using the right one? Should you use more antiviruses? Maybe you want to have virtual machines so as to mitigate the effect of malware, and you can quickly maybe remove them, or you clean the image every day. You start with a fresh image. There are things you can do to make sure you reduce the effect malware can have on your system. And then in case of VPN and credential theft, maybe you ask your employees to change their passwords frequently to have, even though here passwords requirements, if you make it more complicated passwords, still the attackers would take them. So it's not about brute force attacks on password, but it's most of credential theft. So one thing you could have done is to ask the operators to frequently change the passwords, even though this also contradicts with the safety requirements of the ICS system. Here, maybe the password should be easy to remember to ensure that the operators are not locked out whenever there's an emergency. But what you could have done is to ensure that nobody else can register a new user, because that's what the attackers did. They went to the Active Directory and they added themselves as legitimate users. So maybe you can have protection mechanism to ensure that a new user can only be added with a very specific process that involves approvals on multiple locations. And to prevent a network and host discovery, because at the end the attackers did a lot of reconnaissance to understand the specific configuration of the system they were trying to attack. You can prevent this from happening. Maybe you limit the IPs that can access information, even if it's internal, and you don't worry about them still. You may want to to reduce how much the attackers can do reconnaissance to the system, assuming that they can enter anytime and don't have so much trust even within the boundaries of the local network. So you could limit the network and host discovery. On the firmware side, the development phase happens in the adversary's environment, so you cannot prevent or protect against that. But what you could have done, we discussed previously, is the government agencies in your country, maybe they monitor for suspicious purchases of equipment. So if someone just bought your exact equipment somewhere else and they don't have a reason to do that, maybe that's an indication that a development step is taking place. So you may, as a protection or risk reduction mechanism, you want to interface with the government agencies and say, look, this is my equipment. If someone is purchasing a similar type of equipment and they shouldn't, maybe I should be notified, and maybe I do a check to see whether someone has finished stage 1 and they're in the system and they're developing stage 2. SCADA hijacking with HMI client. Here, if you have only a single password to access something remotely, may not be a good idea. Multi-factor authentication can help. So you don't only need the password, but you need a secondary mechanism, for example, a push notification to your phone or some other device to access the system remotely. So two-factor authentication can help with that step of the kill chain. Here, this is the part that the attack takes place, right? And then here, you may have mechanisms to quickly recover, like backup modems or quick transition, but this is part of safety, and this already happens. There was a quick transition to manual operation, and then the operators managed to recover within a few hours from the attack. So exactly, this is the purpose and the usefulness of the cyber kill chain. You go through every step, and you try to see how every step can be addressed individually to ensure that the attack can be killed as early as possible. At every step, you have a chance to kill the attack.